Okay, last two learning objectives. This number 6 is pretty conceptual. It really locks in on our conditions for inference, mainly for normality, for assuming we have a normal sampling distribution, both for proportions and for means. So in the first one, we have the situation of this Lyme disease setting. They added hundreds of thousands of acorns to one area, and they leave the other one untouched. So what they find is that 54 out of 72 mice were trapped in the first area, and then 10 out of 17 mice trapped in the second area. So the violation here is definitely going to be on normality. I mean, we have two different, they had two similar forest areas, and 54 out of 72 is going to be okay. 54 is much bigger than 10. And then if we do 72 minus 54, that's also bigger than 10. And then we have 10 out of 17, but if we go the other way, 17 minus 10, 7 is less than 10. So that would be for confidence intervals, right? We'd look at the counts. But suppose we were doing a hypothesis test. If we were doing a hypothesis test, then we would pool those estimates, right? We would take the 54 and the 10, add them together, and divide by the 72 and 17, and we get this 0.72 pooled estimate for P. So if we take 17 times P, n times P for that smaller sample, we get 12.24. That's okay, but then where we run into trouble is 17 times 0.28 is not greater than 10. So whatever way we want to look at this, we're going to have a violation on assuming a normal sampling distribution because the sample size is not big enough, particularly the 17 mice in the second area. Okay, and the next one, so that would be a test for proportions or a confidence for proportions. The second one, who texts more, males or females? Okay, so these AP students think that the females text more, so this is definitely going to be a hypothesis test. And they have 31 students, 15 males, 16 females. So both samples are kind of small. And then with the males, we have 2 outliers. So with a small sample and 2 outliers, that would violate our condition for normality for the T distribution. Again, you know, I try to tell folks, and a lot of times I will have people that are doing, you know, graduate level research. You know, look, maybe you still have to publish this, okay? And somebody could criticize and say that, you know, the inference may not be entirely valid. A lot of times what I find is that it's not so much these issues, but more representative samples. You know, are we really able to make an inference about a population based on our sample? That's the hardest part, getting a representative sample. It doesn't invalidate all research. Look, we still got to do research and do the best we can. So even if you had a situation like this, I would say go ahead and do the t-test or do the confidence interval, publish your results, but, you know, let people be aware that, you know, that those are some issues or concerns. Okay, and the last one here, a subliminal message is below our threshold of awareness, but may nonetheless influence. Get a 5 on your exam. Can a subliminal message help students learn math? A group of 18 students who failed the math part of the City University of New York skills assessment test agreed to participate in a study to find out. Okay, so all received the daily subliminal message flashed on the screen too rapidly to be consciously read. The treatment group of 10 students, assigned at random, so we like that, was exposed to each day I'm getting better in math. The control group of 8 students was exposed to a neutral message, people are walking on the street. All 18 students participated in a summer program designed to raise their math skills and took the assessment test again at the end of the program. The table below gives the data on the subject scores. So part A just says explain why a 2-sample t-test is more appropriate. So they're helping us out here. If we were going to do a matched pairs test, then we would just take this whole list of differences and this whole list of differences. We put them all in one list, and that would be our matched pairs. So this is going to be a 2-sample t-test, but what's a little bit confusing is that we do have some pair differences, right? We have the differences of the treatment group. So what we're trying to see is how much did the treatment group improve, and then how much did the control group improve, and then if we compare those differences, we look at these improvements on average to these improvements on average. That's a two-sample t-test. So you do have a pairing aspect to this, but we add the extra layer to it that we want to see which pair differences on average were greater. So that's what makes it a two-sample t-test. It wouldn't make sense to just take one list. In a pair differences t-test, we just have one list and we compare it to one number, or we compare it to 0. Here we have a treatment group and a control group. They're independent of each other, so we want to compare their differences. That's two different samples, two different populations. Okay. And then part B, we have the box plots from Fathom. Hopefully we know what we want to talk about here, right? SOCS, right? SOCS, SOCS. Shape, outliers, center, and spread. So the shapes for both of these, we would say something, hopefully keeping in context, but the shape of the treatment group and the shape of the control group are both roughly symmetric with no outliers. Okay, so we covered S and O, no outliers. Center, where are they centered? Well, it looks like the treatment group is centered somewhere around a median of 11, while the control group is centered somewhere around a median of 7 or 8. Okay, so the treatment group on average seems to have a higher center than the control group. And then for the spread, it looks like the treatment group, if I look at the IQR, compare IQR to IQR, the treatment group seems to have generally a little less variability than the control group. The ranges might be about the same, but I would say, if I had to guess, treatment group has a little bit less variability because the IQR is significantly smaller. Even without looking at standard deviation. So just make sure you talk about SOCS in complete sentences and keep it in context, right? Part C, do the data provide convincing evidence that subliminal messages help students learn math? So this is a long one. So we would do a hypothesis test template for that one, right? And our parameters of interest would be two different means. Mu sub 1 would be the true mean difference for the treatment group, and then we have mu 2 Let me just make sure I'm listing those groups correctly, right? We call them treatment and control. Yeah, people walk across the street is kind of your control group. Okay. The null hypothesis would be that they are equal to each other. And again, we could do the differences if we wanted to. I think you all get the point. And then we want to see that the treatment group improves more than the control group. Right, that is the hypothesis, that if we give them that particular subliminal message that they're going to get better at math, that they will get better at math. Okay, so, and we could have the differences like we laid out before. Subjects assigned randomly. Okay, we just have to read the narrative to see, there it is, assigned at random. So we're good. Okay, and then for normality, remember we're doing two-sample t-test here. So our box plots show we're roughly symmetric with no outliers, so we're good on that too. And we can just state that there. They gave us the box plots. Okay. And then both samples are independent of each other. and we're taking less than a tenth of the populations of interest. Okay, so remember, anytime you see lists, we should go to stat and edit, and let me just double check. I think I have my list in there. It's the same list. Yep. Okay, so you're going to go to stat and edit and make sure you enter those two lists, or on the Nspire, you're going to have to create the list, maybe call one of them treatment, one of them control. Okay, and then we're going to run our test. So remember, this is a 2-sample t-test, so we're going to stat, test. If you have an Nspire, you're going to stat and test also, but not confidence interval. You have a separate item for that. So here's 2-sample t-test right there, number 4. Jumps up to me. Okay, and what we have this time is data. So you can pick the data here. We do have the data. And let me just double check. L1 is the treatment group, and L2 is the control group. So I have to keep that in mind. I want the treatment group to have a higher average score than the control group, and I never want to pool. Okay, so take a look at that screen for a second here, right? List 1 is the treatment group, list 2 is the control group. So I want to show that L1 is on average greater than L2. So we calculate, and I get T is 1.9, p-value 0.038. And this is a 2-sample t-test now, not 2 proportions of t. Okay. So if alpha is 0.05, let's just double check here. They don't really give us a value, so you have to just pick that on your own. I think generally we've kind of done the same thing. We've used 0.05, so also say if alpha, we would reject H0. Okay, or more simply put, the subliminal messages seem to have an effect, a positive effect. People that got that subliminal message that they get better in math seem to do a little bit better on average, significantly. Okay, and the last question is, can we generalize the results of the population of all students who failed the math part of the City University of New York Skills Assessment Test? So let's take a deeper dive into what they told us about who took this. A group of 18 students who had failed. Okay, so they the assessment. So that's a sample of the population we're interested in. Students that failed agreed to participate in a study. So that's where we dive away. We didn't take a random sample of people that failed. Right? We got 18 students who agreed to participate. Which could make it hard, and like I said before, I think this is a bigger issue than a condition for normality. Making sure that we have a representative sample. This might not be representative of that whole population because they weren't randomly selected. Okay, so Friday I'll look at the Frappy Notebook question with you, and hopefully you have a real easy test coming up for Chapter 10.